Hi, my name is Benedict L. I work at the Fraunhofer Institute for Experimental Software Engineering. We work on a virtual test bench.
So there is some experimental software happening here and a virtual test bench for the automotive?
Yes, exactly. This is a showcase on how to use our software solution, Feral, in a virtual test bench to enable the assessment and the validation of autonomous driving functionality. So, in this demonstrator, I take over the role of a testing engineer together with my colleague Stefan, and we take over the role and are currently in this scenario. We develop a driving function, and we want to test if that function works as we expected or if we have broken anything. So yes, so we now imagine that we have just uploaded our newest version of the adaptive cruise control. We modeled that with ANSYS Skate. And now we run the automated testing pipeline. So we have several configurations here. We test it now with 40, 60, and 80 kilometers per hour and see if our current implementation still passes the quality gates that we have previously defined and that the previous implementation was able to hold. So maybe for a general information while this is running, the showcase of this is a co-simulation framework that enables us to do this validation and this verification. We just saw that 40 kilometers works fine. As you can see in the screen here, the front vehicle does some erratic braking and some erratic movements, but our ACC that tries to reach 60 kilometers is still able to hold the distance and everything is working. So now we continue to the last test case. We want to know if the system still works when it runs on 80 kilometers. So I'll just start the last one. Start the last test run. If you come back, you can see, okay, we are going way faster in the next one, and we will see if that still holds, if that still works. But okay, we see, oh, there was a mistake. That's not good. So our automated pipeline, our Feral CI pipeline, that is a continuous integration pipeline, we were able to see that there was an error. So now we go into the interactive debugging phase and see what we what we broke with our last update and try to figure out what's going on. Here you can see what is the heart, basically. I'll just reinitialize so everything is loading, so we have a fresh run. The heart of everything, the heart of this system is the Feral co-simulation framework with a simulated CAN bus. Once the simulation is restarted, we can see that this co-simulator connects the different models of the sensors, of the actors, and of the driving functions, and everything is done in a separate and different tool. These tools usually have the issue that they are not able to communicate because they are modeled in a heterogeneous system and in heterogeneous tools. And with Feral, we can combine those and sync those in a simulation where everything runs in the same environment. My colleague will now activate the adaptive cruise control, and then we can see that the messages go through the virtual CAN bus. The sensor information reaches the ACC module, and the ACC module can write back the messages that go to the actor. Now we want to see if the system is able to recover from stress on the CAN bus and how resilient the system is to errors. So we start our Feral noise injector, and we see that the messages get thinner. They're fewer messages are delivered to the system, and also the brake system gets weaker as we continue to fill the limited bandwidth of the CAN bus with noisy data. So now I increase the rate of random data, and we see that there is a really tough issue because the ACC module is no longer able to publish a brake signal. And what we will see from my colleague with the connected vehicle, that if he now tries to, for example, increase the speed or decrease the speed, he will have trouble controlling the ACC module. Yes.
All right. So
please.
What's the advantage of doing everything virtually?
The advantage of doing and testing virtually is that it saves a lot of time and cost for the development. We have seen just right here that we had a small crash and the vehicle starts to accelerate without the driver to really do anything, and we have a very tough crash, which may not happen, of course. If we did that in hardware, for example, that would be very cost intensive and very, of course, dangerous for anyone testing this. Yes, and if you wait, for example, for all the different departments to combine to create the hardware and test everything in a hardware in the loop, and then later check that there's an error or a mistake done in the architecture already, this is very costly and very...
In the automotive industry, is a lot of this is happening, the virtual testing, or is it a brand new thing what you're doing, the way you're doing it?
The automotive industry is starting to adapt the virtual testing. And there are a lot of ways this can go. A lot of tool vendors also provide tools for this and to do the virtual testing already. But there are a lot of technology gaps that we are filling. For example, there is a lot of once an OEM or once there is they decided for a tool, it can happen, or it is usually the case that there is a vendor lock. Yeah, so you have to use everything by one specific vendor. And with our system, it is possible to be way more flexible and way more independent of other tools, while still being able to include those.
It's ready now? It's launched?
It is launched, yeah. It is a licensed tool. It is already in use by Tier 1 supplier.
Yes.
And this co-simulation framework is continuously being developed, but also on a state where it is public, can be published, yes.
All right. Okay, thanks a lot.
Thank you.
Thanks.